particle is perspective of speed v from a horizontal ground, so it goes up there. Angle is theta, and it's got this. Okay, part 1, it just basically says derive the equation of trajectory. That's my x-axis. That's my y-axis, which is positive there. So what I'm going to get, I have a horizontal and vertical. Is how I always set it up, and Stuva both sides. Just take my time a little bit with it. Horizontal, S, that'll be the x. T, don't know, but that's going to have to be the link, so that's what I'm going to have to find. U is going to be v cos theta, and the v will also be v cos theta, and acceleration is 0. And over here, S is y, the vertical component, and I've taken that to be positive, so T is going to come across from here. U will be v sine theta, v, don't know, don't care. And the acceleration is minus g, which is minus 9.8, because I've taken up to be positive. So what have I got? Well, the formula I'm going to be using for both of these actually is the one without the v, so it'll be s equals ut plus half a t squared. So s, that's going to be x equals ut, u is v cos theta, times by t, plus a half a, was a 0, so that'll be 0. And that will tell me that t equals x over v cos theta, and that is then going to feed up into there to get the way to work out what y is. So again, I've got s equals ut plus half a t squared. S is y, and when we get an equation of trajectory, the question says y equals, so pretty obvious I'm going to have y at the front. So y equals ut, so u is v sine theta, times by t, I've just worked it out down here, that is x over v cos theta, and then plus half of a, so that's minus 4.9, half of a, which is 4.9, so it's minus 4.9, and then times t squared, so that's x squared over v squared cos squared theta. A few things happen here. Obviously v cancels out with v, and this will then give me y equals x. Sine theta over cos theta is tan theta, so x tan theta, and it'll be minus 4.9 x squared over v squared cos squared theta, which we wanted for those 4 marks. And then part 2, a stone is projected from the top of a vertical cliff, so that is 100 meters high. This goes up here and it hits the sea 40 meters from the foot of the cliff. So that's 100 meters, and that's 40 meters, and it goes up like so. And it's got to find the 2 possible values of theta. Well, I reckon I'm going to be getting a quadratic then in order to get two values for theta. So I need a quadratic, and I've got cos squared theta here, so I really want to get a quadratic in tan theta. So I remember what cos squared theta is. So I know that sine squared plus cos squared equals 1. If I divide everything through by cos squared, it's always worth doing this in case you forget. Cos squared, so that's sec squared, which is what we've got here, 1 over cos squared is tan squared plus 1. So I can rewrite that up here, but I don't want to, I actually want a coordinate now. This bit here, the coordinates of that is gone 40 across and it's down 100, so it's like that. And when I'm substituting in there, I always like to write down x and y just to check I substitute it in right. So y, that's minus 100, equals x tan theta, so 40 tan theta, and then minus 4.9 times by x squared, that's 40 squared, over v squared cos squared theta. Well, v is 16, so that is 16 squared, and times by 1 over cos squared theta. 1 over cos squared theta is this, so we'll times that by tan squared theta plus 1. And that will give me minus 100 equals 40 tan theta and minus, work that bit out, 30.625 tan squared theta plus 1. And if I rearrange that to get it into equal 0, because I've got a quadratic, 30.625 tan squared theta minus 40 tan theta minus 69.375, that equals 0. Put it into the formula, and tan theta equals minus b, so that will be 40 plus or minus square root of b squared, that's 40 squared, I suppose negative 40 squared, but I put 40 squared, minus 40 times 30.625 times by negative 69.375 all over 2a, so it's 2 times 30.625, so it gives me tan theta equals minus minus 0.9876 or 2.2937, so theta equals minus 44.64 degrees or 66.444 degrees. And so what you've got, if I look at this one, that one's where it comes down like so, and the pink one is the one I've drawn where it goes up like that. That's why we've got two things, either thrown up or thrown down. I've got two possible values of theta, got that, that's 6 done.